Tra la la tra la tra la la tra la la tra la tra la.
Hey there, ladies and gents. So in the past couple of tutorials, we focused on just simply converting between mass and moles or between moles and particles. You can absolutely guess that at some point we're going to ask you to go from mass to moles to particles or from particles to moles to mass. But have no fear, it's no different than the math you've been doing. It's just instead of doing one step at a time, we're going to do two at once. So the only thing you need to do is to be able to read the problem that you're doing and figure out where am I starting and where am I ending, so what order are my conversions going to be in. So in the first problem here, it says how many compounds are in 6.44 grams of CaO. I'm starting with my mass, and I want to get to compounds, which is just another way of us saying particles. So what that means is on my mole map, I'm starting in my mass box, and I want to end at my particle box. So I'm going to use molar mass to get myself into moles first, and then I'm going to use Avogadro's number to figure out how many particles that is. Now, why would it be important for us to figure out how many particles are reacting? As scientists, we like to know what's happening to the compounds, to the molecules that we're working with. So sometimes it is important for us to know exactly how many pieces are in the mix that we're going to use. So let's go ahead and walk through this conversion problem. So we're going to set it up just like we've been doing. So I want to know how many compounds are in 6.44 grams of calcium oxide. So if I look at my mole map, I'm starting with mass. I want to turn it to moles, so I'm going to use my molar mass to help me get into this mole box. Where my grams come from my periodic table, then it's always equal to 1 mole. So if I'm tracking my units, I'm going to have grams of CaO on the bottom and 1 mole of CaO on top. And again, I'll add together the mass of a calcium and an oxygen from my periodic table, and that mass gets me to 56.077 grams. My grams cancel, and what this first conversion tells me is when I do this math, I will no longer have my answer in grams, my answer will be in moles. So I've gotten myself into the mole box on my mole map. My next step is to use Avogadro's number to get myself into particles. So how many pieces do I actually have? So again, I'll track my units. Because I've got 1 mole of CaO on top, I'm going to put my 1 mole of CaO on the bottom, because Avogadro's number is representative of the number of pieces in 1 mole. So you'll notice in both of these conversion factors, I have the number 1 in front of the word mole. That's very, very important. So that 1 mole is equal to 6.022 times 10 to the 23rd pieces. So I'll put that number on top. And now I can go ahead and I can do my math. And I'm going to go ahead and put my answer down here. I'm just going to make this big equal sign with arrows. And I'll put my answer down at the bottom. So when I'm punching this into my calculator, it's going to be a series of 2 steps, or you can use your parentheses. I would take 6.44 and multiply by Avogadro's number. I personally would then hit the enter button and divide by my mass of 56.007. What you can do is you can do this first multiplication, get a number and write it down. And then put your second number on the bottom and do your division. You'll get the same answer either way. So if you punch this into your calculator correctly, since we started with 3 numbers, we'll end with 3 numbers. So we get a value of 6.92 times 10 to the 22nd compounds of CaO. So what this tells me, if I was to dump 6.44 grams of CaO into a chemical reaction, this is the actual number of compounds that I've put into that reaction that are available to do stuff. So that's a huge number, as we learned with our little activity from last week. Now, aside from asking you guys to go from grams to compounds, we can ask you to go the other direction, which is the problem we have down here. So let's say I'm somehow able to get superhuman vision and count the number of pieces of HCl I have in a chemical reaction. I'm counting for millions of years to get myself to this number. So in this case, we're just going to switch the steps. We're going to go from particles to moles and then moles to mass. So we're going to work backwards. So again, I would set it up like a question. So how many grams are equal to 6.3 times 10 to the 26 compounds of HCl? So in this case, since I'm starting at particles and going to moles, my Avogadro's number is going to be the first thing I use, and that's going to go on the bottom of my first conversion. So my 6.022 times 10 to the 23rd compounds will go on the bottom, so my units cancel. and my 1 mole of HCl will go on top. By doing that math, I've gotten myself out of the particle box into the mole box. So now I can use my molar mass to convert it into grams. So again, I know with my molar mass conversion, 1 mole of HCl is going to be equal to some number of grams of HCl. And I'll use my molar mass skills from the periodic table numbers to get an answer of 36.4609 for the molar mass of my HCl. When I do the math in my calculator this time, I'll multiply my 6.3 times 10 to the 26th by this value, get an answer, and then divide it by Avogadro's number. Now remember, when you're using scientific notation, the order of operations is very important. So either use your parentheses in your calculator or use the E button. It'll make your math a lot easier. So I'll multiply these two numbers together and divide by the bottom. And if you do that correctly, you should get an answer of 38,144 grams of HCl. So you can see that would be a whole lot of HCl if we actually reacted that many compounds. If you guys have any questions, please make sure you call a teacher over. Otherwise, you're almost at the end, guys. Keep it going and good luck.